Okay, sounds good. Thanks, Brian. Hi, everyone. My name is Erik Lloyd. I'm the co-founder and CEO of Brink Bionics. And in this workshop today, I'm going to be talking a little bit about what we do at the Engineering Bionics Lab, which is where I did my master's, and at Brink Bionics. Also talk a little bit about prosthetic technology and a kind of wide overview of the interdisciplinary problems that technology is currently facing. And I'll also dive a little bit into human enhancement technology, which is what Brink Bionics is focused on. So to give you a quick background on me, I graduated from McMaster University in 2017 with my Bachelor in Technology. Graduated high school in 2011. I kind of messed around my first year university and then switched into the engineering faculty in 2013. And then finished my Bachelor's of Technology. From there, I got into my Master's in Systems Design Engineering at the University of Waterloo by actually building a bionic hand prototype in my final year of my undergrad and showing that to my future university professor, supervisor, who then let me into his lab as a student as a result of that project. So in terms of what the different PhD and master's students do at the Engineering Bionics Lab, it's focused on a pretty wide range of areas related to neurotechnology. So that's technology that interfaces with the brain or the peripheral nervous system. In this case, with the lab, there's a lot of focus on neurorehabilitation. So things like rehabilitating motor control in people who have suffered strokes, in prosthetic devices, research into assistive technologies for people with Parkinson's, as well as control systems for people with limited mobility using things like EEG. So there's a wide set of different disciplines that are focused on in the Engineering Bionics Lab. And Brink Bionics started out of the lab as a prosthetics company back in 2018, where myself, my master supervisor, Dr. Ning Jiang, and my co-founder, Dr. Jiayuan He, who is another professor at the university, founded Brink Bionics to start building prosthetic technologies that basically took all the best parts of existing prosthetics and crammed it into one device. And our latest prototype is what I have on my desk here. This is the last prototype we built of the axo arm, as we called it, which was short for axolotl, which is a salamander that can regrow its own limbs. And we took that name because with this device, we allowed the user to swap out parts in a hot swap system as things broke down. Fingers breaking on advanced prosthetics is one of the most common problems. So we allowed the user to replace and repair the devices at home without having to go to their clinician, without having to ship it back to the manufacturer. Apart from that, what our team also focused a lot on was artificial intelligence control systems for prosthetics. And this was actually the focus of my master's research. So when AI is used in these kinds of medical devices, it doesn't control the prosthetic or the device for the user, but it acts as a translator between the signals from the nervous system and the complex patterns and relationships that exist between these signals and controls that the arm can understand. So you basically train the algorithms to recognize, okay, if you see this pattern of signals, it means this kind of movement, in a simple sense. And that is what we focused on for the first year of Brink Bionics. The biggest challenge we ran into, I think, was our goal was to be a human enhancement technology company. If you look at any sci-fi games, whether it's this is going back even before my time, like the $6 Million Man, or things like Ghost in the Shell or Deus Ex, all these worlds focus on prosthetics as these superhuman technologies that enhance your performance beyond what you're naturally capable of. And we wanted to do the same thing. We wanted to make that technology a reality. What we realized going through this is, there were about 18 different prosthetic companies in the world all doing the same thing that we were doing. So we looked at this problem and said, is this really the right path? And in looking at the complexity of this multidisciplinary space that is bionic limbs, we realized to get to this human augmentation level prosthetic was going to cost hundreds of millions of dollars. That's money we do not have. And there were research institutes, companies that were further along than we were. So before I dive into what we move to next, I'll talk a little bit about those different interdisciplinary problems, and I'll provide this list so that people can kind of look into it on their own. But there's about 8 different areas that need significant improvement in prosthetic devices to reach that superhuman level of performance. So first one is what my focus was, which was control algorithms in machine learning, artificial intelligence. The next was interface hardware, so invasive implanted devices or surgical procedures like targeted muscle reinnervation, regenerative nerve interfaces, neural implants versus non-invasive, so just a wearable muscle sensor. Then there's the problem of actually providing prosthetics with sensory feedback. So there's the actual sensory feedback hardware, and then the algorithms to translate that, and the implants to translate that into commands that the nervous system and the user can interpret as touch, temperature, things like that. Then there's the load-bearing interface. So whether the prosthetic is going to be wearable as like a socket versus integrated directly into the skeleton using a procedure called osseointegration, which is where titanium implants are put into the bone, they stick out of the body, and the prosthetic mounts onto the user's skeleton. Then the big one in terms of achieving strength and dexterity is robotics and actuator technology. So developing better motor technology, artificial muscles like electroactive polymers or shape memory alloys. Battery technology is a huge problem that the top prosthetics have maybe 3 or 4 hours of battery life. And I'm talking more about the DECA arm and the MPL, sort of the top tier expensive devices. Despite their sophistication in terms of robotics, their battery life is very short. And then the last one that is important, but not so much engineering related, is more surgery related. So different surgical procedures that are being developed to improve the functionality of prosthetic devices, different types of amputation procedures to preserve functionality of muscles in a way that allows them to be used as a viable control input for prosthetic devices. So as you can see, there's a lot of different problems to focus on in this field. Pretty well, many different disciplines of engineering you want to go into: mechatronics, electrical engineering, biomedical engineering. You can get into prosthetics and human enhancement technology. In terms of what Brink Bionics is doing now, we're still a human augmentation company, but we're focusing on the consumer market instead. So our first product is one we're just launching now called Impulse. It's a wearable peripheral neural interface that captures the fine motor movements from your fingers, from your peripheral nervous system, and relays those directly to your game as a control or a command. And it's about 80 milliseconds faster than your conventional mouse inputs. And if you're an avid gamer, you know how important 80 milliseconds is to your reaction time. So we're continuing to work on other technologies in this human augmentation direction, and not all of which I'm able to discuss at the moment. But our goal still as a company is not to just provide technology to help assist people who have lost functionality, but to begin exploring how we can enhance human beings beyond what we're naturally capable of. Now, in terms of how I got down this path in my career, a lot of the things have come, a lot of interesting opportunities have come from building my own projects. So I got into my master's by building my own bionic hand as sort of a test project to see if I could do it, and building algorithms and publishing a paper on that technology while I was finishing my undergrad, and that caught the attention of my supervisor. Then there is looking at another project, which I'll show you a video of, around building a muscle sensor that worked with my Xbox. So let me pull that up now. Which we don't want for this one. Okay. Okay. So let me know if you can see my window. Good.
We can see it.
Okay, great. So in this video, I'm just briefly walking through this adaptive controller input. So I have the Microsoft adaptive controller working with my controller connected to my Xbox. I have an Arduino microcontroller hooked up to a muscle sensor on my arm. And basically, I built this kind of in an afternoon. And what happens when I flex my fingers or I flex my wrist, it'll activate an in-game command. So in this case, I used Call of Duty as a quick example. So if I flex my hand, I shoot, which is cool. So this was something we built just before we went down the path of developing Impulse, our gaming neural interface. And it ended up being a good direction because it caught the attention of the team who actually worked on the adaptive controller at Microsoft. And I've actually been able to speak with them over the last year about neural interfaces in gaming and how these can be assistive technologies for people who have limited mobility and still want to play games, or for people who want to enhance their performance in gaming. So if you ever have a chance to pick up the adaptive controller, just as like a project kit to build things that connect to it, I highly recommend it. It was a lot of fun to work with. So building my own projects has led to some interesting opportunities. So I'd encourage anyone to just start building things in order to explore different areas. I also look for that kind of thing when I hire people. So, for instance, the student and now graduate that I hired to work on the firmware for the prosthetic hand, the reason I hired him, his grades were good, but that wasn't the reason I hired him. He had worked on a project when he was, because he's from India, when he was in India, where it was a hardware system and some software where when people went to donate blood, they would give their cell phone number, and when their blood was used to save someone's life, they would get a text message. So it was a system that would encourage people to donate blood because there would be this direct feedback, positive reinforcement. And I just thought that idea was so cool that I saw the project, he showed it to me, and immediately I'm like, yeah, you're hired, come work on this. And he did a fantastic job building the firmware, a full control interface for the arm for our research team. It was a good decision. So the thing that'll set you apart more as you're leaving, if you decide to go down the university or college path, is everybody coming out of university wants to get good jobs. Everybody will have good grades. You're competing with the I guess the smartest kids from every school. The thing that you're going to set yourself apart with is the things you do that are self-motivated. You want to work for startups or big companies. Building your own projects is going to demonstrate you're self-motivated, you love coming up with new ideas, you solve problems in your own life or in someone's life. You don't wait for someone else to solve those problems for you. So I encourage not to wait. There's so many amazing tools available now that start playing around, building small and simple projects and building your way up. I don't want to take up any more time because I want to leave some time for questions. So if anybody has any questions, I know I flew through a bunch of stuff, but if you have any questions at all, I'd love to hear them.
Hey, Eric, there's actually a question in the chat that says, could BCIs and prosthetics be linked, and what impact would the former have on the latter? It's in the BCI discussion.
Yeah, so in terms of BCIs, I'll focus on sort of central nervous system. If we're looking at non-invasive devices like EEG has a lot of limitations for viable control inputs. Part of it is for EEG, there's very long time delays in the system because you have to collect enough data for the system to make a reliable decision on control output. Second is the interface limitations. Shifting of the system while you're walking around and moving drastically affects signal quality and performance. So I don't see EEG being applicable for prosthetic devices. Peripheral nervous system interfaces are far more viable in completely restoring functionality. Now that being said, implanted neural interfaces have strong applications for control of prosthetic devices and external devices in general. So if you have something like a Neuralink, which is Elon Musk's company, or BlackRock Microsystems, which is a company that also makes high-density neural implants, if you have those types of technologies implanted into the cortical surface of the brain, you can capture the activity of small neural circuits or individual neurons, and that can serve as a very, very reliable, low-latency control input for prosthetic devices.
Okay, thanks so much.
You're welcome.
Does anyone else have any questions? You guys can put them into the discussion chat, or you guys can unmute. Oh, it's up to you guys.
I'm just looking through the discussion chat here as well. Yeah, the competition question is always interesting around prosthetic devices. Yeah, they may not be allowed in Paralympic competitions. If you have a bionic leg that lets you run faster than natural, you will have an unfair advantage. But prosthetics in competitions, there already is kind of an imbalance because you'll have people with different levels of amputation competing against one another. So if somebody has only lost sort of their leg below the ankle versus someone who's lost their leg above the knee, and they're competing against one another, well, the person that's lost their leg only below the ankle still has the power of their knee joint to put into running. So there's already an imbalance in ability in these competitions. So the question is, well, do you provide the person with the higher level of amputation a device that levels the playing field for them? But it's an interesting question. There is no kind of final answer on it. But the same thing comes up with our neural enhancement in esports. If someone is hooked up with cybernetic enhancements and they're playing games, are they allowed to compete in esports? It's another question where it fits into this gray area. In terms of, I see another question, the rate of development as relates to prosthetics, how long do you estimate that it would take for prosthetics to become more functional, more useful than human arms? In like Cyberpunk 2077, which is a good example. It might be sometime around 2077. It depends on the rate of innovation. Prosthetics over the last 10 years saw an accelerated innovation because of the U.S. Defense Advanced Research Projects, DARPA. The money they put into prosthetics research, over I think $120 million or more was put into the development of just one prosthetic device. That was the MPL, modular prosthetic limb, that matches human performance. But to drastically extend human performance to a degree where people will actually want to swap their limbs for prosthetics really depends on the rate of development. In the regular, prosthetic industry device, as it relates to regular devices for everyday people, that rate of development has been very slow. It could be 20 years, it could be 50 years. Now I'm not so sure which it is yet, but we will get there. Just looking. I printed wide lines for video, but what is the potential for situations with human response? So one question around how reaction time and response time might be important in other applications. So in terms of things like driving or flying fighter jets, there are some reaction time advantages where neural interfaces could be extremely beneficial. But yes, in terms of driving, self-driving cars will make a certain amount of those technologies obsolete. But if you're looking at, race car drivers and using neural interfaces one day to directly control the vehicles, part of the excitement of race car driving in competitions is the human aspect of those competitions. I think if it became a bunch of self-driving cars around a track, people might not find it as interesting. It'd be like replacing the Olympics with only robots. Those are competitions we can have sort of on their own, but I don't see it as an issue in terms of self-driving cars replacing the competitive side of driving. But it'll replace the need for any type of sophisticated low latency controls in everyday life for things like driving or flying. Most of the applications for low reaction time come from gaming and esports. There are certainly military applications for those technologies as well. I'm just looking to see if there are any questions. Is it unethical to enhance performance with the use of prosthetics? I mean, you have to ask what unethical, why it would be unethical. If an individual has, right now, today, we can go in and modify our bodies with, tattoos or with plastic surgery to look a certain way. So I'd see prosthetic devices as no more unethical than someone modifying their face or body to look a certain way. It's simply an augmentation that is just like these aesthetic augmentations, only it's practical, it's functional. So I think in terms of the ethics behind it, I look to the plastic surgery industry and available plastic surgeries and the path that has taken as an analog for what prosthetic device augmentation and the ethics behind prosthetic device augmentation will look like. In terms of, do you think that multiple startup small companies and the element of competition will be better than one big company like Google in terms of who can develop the quickest and most advanced prosthetic devices the soonest? Well, it is an interdisciplinary problem. Like the MPL prosthetic was developed by, as I understand, multiple teams. The DARPA program called Revolutionizing Prosthetics, of which my co-founder was a part of when he was in Germany, I believe, is a program that had many different labs working on different technologies, sort of competing against each other for these grants. So yes, the spirit of competition, so to call it, will definitely create faster innovation in the prosthetics market. In the past, two companies, Ottobock and Össur, Ottobock being a German company, Össur being an Icelandic company, have dominated the prosthetics market. Initially the few companies that have popped up in sort of the early 2000s, the RSL Steeper with the bionic prosthesis and Touch Bionics with the iLimb, the big companies were buying them out. But now there's so many small prosthetic companies that the big companies can't necessarily keep buying them out. So I think that the increase in the number of these small prosthetic companies will force the big companies to innovate. My one co-founder was working at Ottobock, working for them on research projects. The one problem they had that he noticed is that innovations would be developed in these companies and then shelved because they would compete with existing products. And because the company dominates most of the market, they don't need to release new innovations. But the competitive environment, I think, will force the big companies to innovate faster. Now, what conditions do you think there need to be to maximize bionic innovation? Military programs have been the largest facilitator of that innovation. The war in Iraq was an accelerator and I think a driving force behind the revolutionizing prosthetics program. So as unfortunate as it is, it seems that greater conflicts in the world are the things that seem to drive prosthetic development. The injury of soldiers and taking care of our veterans as they come home requires more sophisticated devices and research into better prosthetic technology. I hope that that doesn't happen where we have other wars that require great innovation in prosthetics, and I hope that instead, Vishwa, to your earlier point, that it comes from the spirit of competition in the market. So I've gone through kind of all the questions that I've seen in the chat so far, but if anybody has anything else, even around career path, if you want to go into this industry. Oh, hold on, I've got another one. Yeah, so conditions, as I mentioned previously, the conditions for prosthetics was the wars have accelerated the innovation of prosthetics, but kind of a summary of my previous point is the hope is that, the adaptive controller question. When did you build the addition to the Microsoft? Last year. So it's a project I did on, I think, a Saturday or a Sunday last year. Well, in some ways, I guess we have to define what we mean by cyborg. So in terms of the non-invasive technologies that are available today, this technology is already starting to become a thing. If we refer to cyborg as someone who's using maybe neural interfaces to enhance their performance, well, every time you put this on, you become a cyborg. In terms of invasive technologies, I think it's going to come much sooner than people realize. And without discussing what Brink Bionics is working on in the background, I'll leave it at that it's much sooner than people realize. Any countries that support, I would say initially it was the United States, because of their focus on developing advanced prosthetics for their soldiers coming back injured from the war in Iraq and Afghanistan. So That would have been the biggest funding. There seems to be a shift in focus from towards more invasive technologies now from DARPA, which is the defense research arm of the U.S. government. Ideal career path. Yeah, there's a number of different directions. You know, I talked about the multidisciplinary complexity of prosthetics, but you could get into work on the more robotic side through mechatronics. You can go into the research. I mean, the cutting edge of the field is in invasive technologies, in the development of more sophisticated control algorithms. So you're looking at your master's or PhD level research, a lot of which some labs in Canada, like the lab at the University of Waterloo, is doing research into non-invasive control systems. But the US does a lot of research into more invasive technologies, implanted devices. But in terms of going from high school to undergrad to grad school, lots of different fields in engineering: mechatronics, electrical engineering, biomedical engineering, software engineering can get you there as well, depending on what you want to focus on. There's quite a few different areas of engineering you can focus on to get there, but most of them are in the engineering space or in the medical space. So if you want to work on osseointegration implant procedures, so that is the surgery of implanting the titanium into what's left of someone's limb so they can mount a prosthetic on their skeleton, then you're going down the medical and surgery path, which I know almost nothing about. So yeah, I hope that answers your question.
Okay, actually, I'm gonna have to stop the workshop right now because it's already 2:40. But thank you, Eric, for coming. This was really inspiring and inspiring for all of us and very insightful. Thank you very much. For everyone who's here, you guys can go on to the next portion of the summit, which will be the youth panel. All right, thank you everyone for coming. Thank you, Eric.
Bye. Okay,
Thank you.
you very much. Bye. Have a nice day.
Bye.
Thank you.
Bye.
Thank you.